Robert Boyle was a chemist, natural philosopher, physicist, and inventor. He was born in Lismore, Ireland on January 25, 1627. He was born into a wealthy family and received the best education. He studied philosophy, religion, math, physics, and chemistry. He is mostly known for Boyle's law, which shows the relationship between pressure and volume of a gas. Today, Boyle is often referred to as the first modern chemist.
Boyle's law states that the volume of a given amount of gas held at a constant temperature varies opposite with the pressure. As volume decreases, pressure increases, or vice versa, with a constant temperature. This happens because decreasing the volume means that there are more collisions between particles, which increase the pressure. Also works the opposite way.
P1V1 equals P2V2. P equals the pressure of the gas, and V equals the volume of the gas, but the temperature must be constant. P1V1 represent a set of initial conditions for a gas. P2V2 represent a set of new conditions.
If you know 3 of the 4 variables of the equation, you can solve for the remaining variables by rearranging the equation.
Step 1, label what is given, so pressure and volume. Step 2, use Boyle's law formula, P1V1 equals P2V2 to get your new equation for what you're solving for. Step 3, plug in your numbers into your new equation. Step 4, make sure your answer's in the correct number of sig figs. Voila!
If a sample of helium is in a 1 liter container is 0.988 atm, what is the pressure in a 2 liter container? So we solve this by using Boyle's law, which is P1V1 equals P2V2.
Now.
Right, so we're given 1 liter, so that's the volume of our first one, and we're given the pressure of the first one, and we're also given the volume of the second one. So we need to find the pressure of our next sample. So what we do is we have to get pressure by itself. So we divide by the second volume, divided by the second volume, and pressure of the second is going to be equal pressure of the first, volume of the first, divided by volume of the second. And so now all we have to do is put the information in this equation, and now we get pressure of the first one is 0.988 atm times 1 liter divided by the volume of the second one, 2 liter, and this is equal to the pressure of the second. So when we do it in our calculator, parentheses, 988 times 1 divided by 2, we get pressure of the second one is equal to 4.494 atm. And that is your final answer for this problem.
A sample of neon gas occupies 0.200 liters at 0.860 atm. What will its volume be at 29.2 atm? So we know that Boyle's law equation is P1V1 equals P2V2. So we know that 0.200 liters is volume and P1 will be 0.860. We also know that P2 is 29.2 atm. So So we need to get V2 by itself. So we're gonna divide by P2 on both sides. So our new equation would be V2 equals P1 V1 divided by P2. Forgot the 2. And now we need to plug everything into our new equation, which would be V2 equals 0.860 ATM times 0.200 liters. Divide by P2, which is 29.2 ATM. So I plug all of this into my calculator and I get 0.0058, and I round that to 0.006 liters, right? Liters?
Air trapped in the cylinder occupies 145.7 milliliters at 1.08 atm pressure. What is the new volume of air when the pressure is increased to 1.43 atm by applying force to the cylinder? So we are going to use Boyle's law, which is P1 V1 equals P2 V2. We know the first volume because that is given to us first, and it's 145.7, and our first pressure is also given to us as 1.08. Our second pressure is also given to us, no problem, and it's 1.43, and it's asking us to find V2. So in order to do this, we need to get V2 by itself, so we divide the entire equation by P2, and these cancel out, leaving us with V2 equals P1 V1 over P2. So now we plug in our numbers, and we have V2 times 1.08 times 145.7 divided by 1.43. Once we plug this into our calculator and simplify it down to our sig figs, we get 1.10 times 10 to milliliters, and that is our second volume.
Control. Great job in this thing.
Next one, zebra.
Put your finger on the hole. There you go.
Do it again and make it look really big. As big as it can, and if it pops,
Just say the fluence
Ready?
before he starts swimming.
Wait, is it gonna pop?
More.
No, not that
Make it blow up really big so you can go.
much. Oh my god, that's good.
Are we gonna make it explode?
Yeah. Perfect. Good. Yeah. There you go. Now cap it.
That was what we did.
Now squeeze it.
Oh, I should get my.
It's clear.
Let me go get it. You go
Alright.
do that.
I'm just pressing it a little bit so it moves up and down, but I'm not actually getting it out.
Alright, now do it all the way. Alright, now do it one more time, but really slowly, so we can explain that as volume goes down, pressure goes up.
It's just like
So, as pressure goes up, volume goes down and it drops to the bottom somehow.
wow. It's not just a float. Cool. Would you like to see?
Go.
Hello.
You're not videoing right now, are you?
A little bit, kind of. Now I am.
Move, Kimberly, move.
No, my balloon.
You got stuck again.
Oh.
There we go. It's not stuck. Go. No, it is stuck. Go.